Hello everyone, so today I'll be discussing question number 46 of GATE 2022 set 2. Which of the following statements is /are correct? So in this problem, 4 options are given to us and different statements are there. So we need to tell which of the statements are correct. So statement number A is, if a linearly elastic structure is subjected to a set of loads, the partial derivative of the total strain energy with respect to deflection at any point is equal to load applied at that point. So this is statement number 1 or A. Statement B is, if a linearly elastic structure is subjected to a set of loads, the partial derivative of total strain energy with respect to the load at that point is equal to the deflection at that point. Statement C is, if a structure is acted upon by two force systems PA and PB in equilibrium separately, the external virtual work done by the system of forces PB during the deformation caused by another system of forces PA is equal to external virtual work done by PA system during the deformation caused by PB system. So this is statement number C. Statement D is, the shear force in a conjugate beam loaded by M by EI diagram of the real beam is equal to the corresponding deflection in the real beam. So these 4 statements are given to us. All these statements are corresponding to different theorems. So we need to see which of these statements are correct. So it's a 2-mark question and reference for this lecture for this type of problem is given here. Each statement in this question is based on a particular theorem. Let's see those theorems one by one. So the first theorem is Castigliano's first theorem. So first statement is based on Castigliano's first theorem. So Castigliano's first theorem says that the first partial derivative of the total internal energy or the strain energy in a structure with respect to a particular deflection component at a point is equal to force applied at that point and in the direction corresponding to the deflection component. So it means, it says that the first partial derivative of the strain energy with respect to the deflection component, so delta, is equal to force applied at that point. So P, let's say P is the force. So this is the Castigliano's first theorem. And the statement which is given to us is that if a linearly elastic structure is subjected to a set of loads, the partial derivative of the total strain energy with respect to deflection is equal to applied load. So this is the statement of Castigliano's theorem first, so it is correct. So option number 1 is correct. Let's see option number 2 now. So option number 2 is based on Castigliano's second theorem, directly taken from Castigliano's second theorem, which says that the first partial derivative of total internal energy or the strain energy in a structure with respect to force applied at that point is equal to deflection at that point of application of force. So this means that delta U by delta P with respect to force it is given is equal to deflection at a point, so delta. So this is the statement for Castigliano's second theorem and this is the same as option number B. Therefore option number B is also right because it is Castigliano's second theorem directly. Let us analyze option number C now. So option number C is based on Bette's theorem. So Bette's theorem, according to this theorem, the virtual work done by P system of force in going through the deformation caused by Q system of force is equal to virtual work done by Q system of force through the deformation of P system of force. So if we want to analyze this statement, we can draw it like this. Suppose this is the simply supported beam we have, and let us say it's a P, having a P system of force. So let us say it is having P1 and P2, two forces P1 and P2, and because of P1 and P2 this beams deflects as this. Now let us consider one Q system of forces as well. So let us take another simply supported beam here, and it is having a Q system of force, means let us say it is having one Q1 here, and let's say it is having Q2 here. So because of this Q1 and Q2, let us say this beam deflects like this. Okay, so let me make these markings at the location of all the loads like this. Let us name different locations also. Let's call it as location A, B, C, D, E and F. The deformation due to P system of forces at location E, where the Q1 acts, is, let's call it as delta E. Let's call this as delta F. Similarly, for Q system of force, the deformation at this location, let's call it as delta C, and this deformation, let's call it as delta D. Now, according to Betti's theorem, the virtual work done by P system of forces in going through the deformation of Q system of forces. So we can write that virtual work done by P system of forces as P1 multiplied by the deformation at the location of P1 in Q system of forces plus P2 multiplied by deformation in Q system of forces at the location of P2, which is delta D, is equal to the virtual work done by Q system of forces, which is Q1 multiplied by delta E plus Q2 multiplied by delta F. So it is the statement for Betti's theorem. So this statement is directly given in option number C, hence the option number C is also right. Now let us analyze our last option, which is option number D. So option number D is based on conjugate beam method. Let us see the first theorem for conjugate beam method. So that theorem says that the slope at a point in the real beam is numerically equal to shear at the corresponding point in the conjugate beam. So shear in the conjugate beam is equal to slope at a point. But in our statement it is given that the shear force in the conjugate beam is equal to deflection in the real beam, but it should be slope in the real beam. Therefore the statement D is wrong. So in our question it is asked that which of the following statements are correct. So option number A, B and C are correct, while option number D is wrong.